Assalamu alaikum wa rahmatullahi wa barakatuh. Inshallah, today me, Muhammad Al-Muteri and Badr Al-Ukab will be talking about a journal paper which talks about the design and performance analysis of centrifugal pump, which was written by Kin Chu Thin, Mia Kang and Kin Maung A. The paper focuses on the design and performance evolution of a centrifugal pump, especially a single stage and suction centrifugal pump. The pump consists of two main parts, the rotating impeller and the stationary casing. Water enters the pump actually through the impeller and exits radially. The casing guides the liquid to impeller, which is high velocity, is converted into pressure, and then directs into a way. The design and performance analyzes aim determine the optimal operating point of the centrifugal pump, which is widely used in domestic, irrigation, industrial and river water pumping system, including those manufactured in Myanmar. The pump is driven by a 1 horsepower electric motor, and the design methodology employed is the Berman method. The specified head and flow rate of the pump are 10 meters and 0.179 meter cubed per second, respectively, with a motor speed of 2,900 RPM. A low specific speed of 100 is chosen, and the impeller is equipped with 9 blades. To assess the performance of the centrifugal pump, various factors are considered, including shock losses, impeller friction losses, volute friction losses, disc friction losses, and recirculation losses. These aspects are taken into account after dimensions of the pump have been determined. In summary, this paper provides an overview of the design performance analysis of a centrifugal pump, highlighting in significance in numerous applications and in manufacturing process in Myanmar.
Thank you, Muhammad. As we say, pumps play a crucial role in a wide range of applications, both in industrial and residential settings. They come in various types, sizes, materials of construction to suit different needs. The field of pumping equipment has witnessed significant advancements over time. This primary function is to transfer liquids from areas of low pressure to high pressure. This is achieved by creating a pressure difference that causes the liquid to move in the desired direction. Centrifugal pumps are particularly popular and find extensive use in irrigation, water supply plants, power plants, sewage systems, oil refineries, chemical plants as well, hydraulic power services, food processing factories and mines. These versatility makes them suitable for almost any application, including water pumping project, domestic water supply, industrial wastewater removal, and raising water from underground wells to fields. The main mechanism through which a centrifugal pump imparts energy to the fluid by utilizing the changes in velocity that occur as the fluid passes through the impeller and the fixed passages within the pump. This conversion process involves transforming mechanical energy into hydraulic energy, allowing the fluid to reach the desired location or elevation through the centrifugal force, which is exerted by the impeller blades. The input power for a centrifugal pump is typically supplied by a prime mover, such as an electric motor or a small engine, while the output energy is the form of hydraulic energy transferred to the fluid being pumped. In a centrifugal pump, the liquid is forced into a set of rotating vanes, usually due to atmospheric pressure or other external pressures. These vanes are enclosed within a casing or housing, which facilitates the energy transfer to the fluid through centrifugal force. When a pump transfers mechanical energy from an external source to the flowing liquid, some energy losses occur during the conversion process. The Euler equation is commonly used to predict the energy transferred. These energy transfer quantities involve losses that occur between the fluid power and mechanical power of the impeller or runner. Therefore, centrifugal pumps experience energy losses. These losses in centrifugal pumps can be categorized as internal losses and external or mechanical losses. Internal losses refer to hydraulic losses or losses due to blade friction, variations in effective area or changes in flow direction at the sealing point between the impeller and the housing, particularly at the rotary shaft seals. On the other hand, external or mechanical losses include losses by friction or sliding surfaces such as bearing friction or seal friction. Pumps have diverse applications and are crucial in transferring liquid from low to high pressure. Centrifugal pumps, which are widely used due to their versatility, find application in various industries. They convert mechanical energy into hydraulic energy using centrifugal force generated by rotating vanes enclosed within a casing. Energy losses occur, of course, during this conversion process, including internal losses, which is related to fuel dynamics, and external losses associated with mechanical components like bearings and seals.
MashaAllah, a brief explanation. Talking about the designing of centrifugal pumps involves numerous variables that are interconnected, resulting in multiple possible designs of the same operating conditions. One challenging aspect of the design process is predicting the imperial head slip, which refers to the difference between the theoretically calculated head based on the number of imperial vanes and the head derived from the net power provided to the fluid passing through the impeller. To begin the pump design or selection process, specific specifications need to establish the meet various equipment requirements. These specifications outline the desired performance and operational characteristics of the pump. A key parameter used in classify impellers is specific speed. It allows the classification of the impeller based on their performance and proportions, irrespective of their actual size or operating speed. By considering specific speed, designers can compare and evaluate imperial design effectively. The design of centrifugal pump is a complex task due to the interdependencies of various variables, predicting impeller's head slip and establishing appropriate specification of critical steps in the design process.
Thank you, Muhammad. So we can say, as a result, in order to achieve the desired performance of a pump, an input power is necessary, and this process involves the efficiency of energy transfer. Pump efficiency is determined by the ratio of the pump's fluid power to the power provided to the pump shaft. One key aspect of the pump's head flow curve is the best efficiency point. At this point, the pump operates in the most cost-effective manner, considering both energy efficiency and maintenance requirements. In simpler terms, in order for a pump to perform effectively, it requires an input power that is efficiently transferred to the fluid. The best efficiency point on the pump's performance curve is important because it ensures the pump operates in a cost-effective manner in terms of energy consumption and maintenance needs. The efficiency of a centrifugal pump is affected, of course, by factors such as hydraulic losses, friction losses within the pump's components, and losses due to leakage. The design of the impeller was aimed at reducing the width of impeller, which resulted in an increase in the friction losses within the passage. As a mitigation, this increase in friction loss, a radial flow passage configuration was implemented on the impeller plane. Friction losses occur when the fluid comes into contact with solid boundaries, including stationary vanes, impeller casing, disc, and diffuser. These friction losses contribute to the dissipation of energy in the system, of course.
Analyses were conducted to determine the losses in the centrifugal pump by determining the values of flow rate Q and head H. at different varying points. Centrifugal pumps are machines that are utilize the kinetic energy fluids to increase power within rotating impeller. The delivery had the help of centrifugal pump depends on the flow rate, and this relationship is representative of the performance curves to generate the characteristic curve of centrifugal pump. Thank you very much. We tried to explain a brief explanation on this study journal, and inshallah we did well.
Thank you so much, and hopefully this gives a brief summary about the overall journal, and inshallah